Welcome to Keith's Shop again, and this is a continuation of the Cyclone Separator dust collector that I built. On this particular video, part 5, I'm going to talk about replacing the blower with a larger impeller and larger horsepower motor, as well as tying up a few loose ends that I didn't get to in video 3. I hope you enjoy it. Thanks for watching, and as always, I appreciate any feedback.
Okay, we're going to start by looking at the various build of the upgraded blower with the 14-inch fan. Again, the first version that I built on the Cyclone Separator used a 2 horsepower 12.5-inch blower from Bridgewood single stage dust collector. I was able to purchase a new fan, Continental fan, in a closeout from Oneida probably about 5 years ago now for I think it was about $65 or so. Recently I found a 4 horsepower compressor motor on Craigslist for about $25. The nameplate's a little scratched, but I believe it is a 15 amp 220 horsepower motor. The one issue with the fan here though is it has backward inclined fins, and it needs to spin the opposite direction of my current fan in the Bridgewood unit. So that meant I really had to take into account the direction of rotation on the motor. It either had to be reversible or rotate in the correct direction. It also means I had to modify how I mounted the blower a little bit to the dust collector unit, because coming out the other side of the blower with the change in direction brought some challenges to that. It mounts to the motor shaft with a Browning tapered, split tapered bearing, and I'll show that here next. There we have. So here's with the bearing mounted, or the flange mounted for it on the bushing, and it actually came with a split taper bushing to mount to a 7/8 inch motor shaft, and the motor I'm using has a 5/8 inch motor shaft. So I was able to find one, I think it was on Amazon, for pretty inexpensive. Fits right in. It's a H type split tapered bushing. I then mounted the fan on the motor so I could check clearances and figure out exactly how I was going to mount the motor to the dust collection blower itself. And I came up with this design for it. So this is the motor with the shaft coming down here and the tapered bushing here. And this piece here, the rose-colored piece here, is a 3/4 inch plywood that was the cutout from the top of the blower assembly. So I made it just a little bit bigger than the fan itself, so I could assemble this as a complete sub-assembly and lower it down inside the blower housing. The brown hatched piece here is again 3/4 inch plywood, and that's part of the motor base. So I cut a hole out of the center of that with about a 1 inch clearance around the perimeter for the motor, and then routed a little bit more down into the top blower plate to allow airflow in here. The airflow comes in here and then up through the motor to cool it. The other thing that I did there was I took a Forstner bit and I cut this recess into the top blower plate to allow me to lower the fan or the motor down into that slot, yet still keep a little bit of material here as a seal against air infiltrating in from the outside. Then I was able to put a mounting assembly up here on the top that I fastened the motor to. Notice on the fan it's slightly tapered at the top end, and that brought some challenges for how I was going to mount it into the blower and how I designed the blower, and we'll see that coming up here, how I dealt with that. It was roughly, the clearance on the outside was about 4 inches, and I didn't want to make the whole thing about 6.5 inches wide. I didn't think that would be very efficient, so I think I made it 6 inches with the inch clearance at the top, or the bottom, and an inch clearance at the top. That way I could go straight into a 1 inch or a 6-inch pipe on the output too. Okay, so I need to make a scroll kind of, or a spiral assembly for mounting the sides into the top and bottom plates of the blower assembly. And the first thing I tried to do was individually, you'll see the design setup I have on the next page here, but try to do the spirals independently, and they didn't work out very well. So I actually filled in those grooves with the body putty, similar to I used earlier in the project, and sanded it flat and started again, and I opted to make a template instead. So this template shows the diameter of the fan itself, so I can know clearances, and the clearance here at this point, the narrowest point, I think was about 3/4 of an inch wide clearance there. And then I want the radius to get larger and larger and larger until I have a maximum radius here, and this is about 6 inches wide here. So anyway, so I made this, and then I made it actually just a little bit narrower because I used a template bushing in my router with a 1/8 inch straight bit to round the grooves around both sides, and use this side here as a registration against the side of the blower housing, as well as this reference flat edge against the side of the plate of the blower housing. When I was done routing this, I just took the template off, remounted this reference plate onto the other side, and flipped it over, obviously, so it's a mirror image, and did the bottom plate too. Later then I cut the circle out of here, on, actually not here, but on the template itself at the top piece, that allows access to put the fan down through the top. So how I did this, how I cut the spiral, is I first took a dowel, and I actually used a lighter gauge wire, but you can do a string around it, wrapped it around a number of times, screwed it to the very center of where the fan is, stretched this out till it was at the largest radius of the spiral, and then I just took a pencil and gradually wrapped it around, and as that wire or string starts wrapping around this dowel, it gets closer and closer to the center, and that's how I drew the do the spiral on this. Now the spiral, if we go back to the previous slide here, it's only about 7/8 of the way around. It isn't a full 360 degrees, so I take that into account, and it's only about 7/8 of the circle. So to calculate the dowel diameter, you take the maximum radius, subtract off the minimum radius, multiply by pi, 3.1415 is get you close enough, multiply by 7/8 because I'm only going 7/8 of the way around the circle, and that should give me the correct distance for changing the spiral. And in my case, I think the dowel was just a little under 1 inch in diameter. Now for the blower scroll side, I looked at different options for doing that, and I actually saw on another YouTube video where someone had used some vinyl they got from either Home Depot or Lowe's, and it was thicker material, and I didn't really want to try to bend 1/4 inch material around. So what I thought would be really do well is they call it a plastic panel. Comes in 4x8 sheets, and it's about a 1/16 of an inch thick, so it bends very easy, and that's why I use the 1/8 inch router bit to route a groove in both the top and bottom panels, and to mount this plastic panel in place. Now, one of the sides of this panel is textured and one is smooth. So I put the smooth side on the inside of the blower and the rough side on the outside. And you'll see some pictures as we go along on the assembly, the difference there. So in fact, here it is. Here you can see there's a rough side on the outside and then a smooth side on the inside. So I was able to fit that in there. I think this was actually the first go around trying to line up the grooves, and it didn't work, so I ended up filling them in, as I said earlier, and making the template and using that. You can see I've lowered the fan in here just to make sure everything fit, and everything looks good there. Then I took it, and this is with the second go around of the groove, so this is correct now. I made some mounting posts in here for attaching the bottom and the top together, and we see that there's a 6-inch hole here that matches the pipe that's going down to the center of the Cyclone cylinder. And I think I did 2 different layers here, and these are roughly matching the tapered of the blower fan. So I didn't want to again make the whole thing as thick as it did, so I just gradually tapered it down, and then this clearance here on the inside is going to be I think like a 6 1/4 inches to allow me to put then a round pipe at the exit point. So then I went ahead and put the inside panel in, and you can see I actually, when I finally got it in place, I actually put some caulking between the panel and a couple of the mounting places at the tip of the vertex where it's at the narrowest inside, and I screwed them in place there. And you can see actually on the side of the panel coming in here, I screwed it there also. I also added a tapered transition, 4 little blocks at the side here that helps transition from the rectangular slot to the round slot for the pipe. Then I'm going to cut off the corners on the bottom plate. This allows me some clearance for the pressure gauges that I'm mounting in the top part of the dust collector. When I was done with this, then I went ahead and caulked all the inside seams also of this before I went further. At this point in time, it shows the motor mounting piece at the top fastened to the blower housing, and I've also added the exit pipe here on a straight flange piece here. And I also am showing when I did some testing on this blower, I installed just temporarily a 6-inch input pipe. Again, this will be going down, this kind of pipe will be going down inside the cylinder of the Cyclone separator. Then once all that was done, I went ahead and painted things up and made it nice like the rest of it. Again, this is with the corners cut off now, so there's room for the gauges there. And the top plate didn't really come into play, so I didn't have to cut those off. And once it was painted, I went ahead and caulked all the outside edges. It probably was a little bit of an overkill, but I went ahead and did that anyway. And I also caulked around the pipe here on the exit pipe. And those cut off corner pieces, you can see where that sort of comes into play here. This is the back side where I'll install the pressure gauges. And you can see I've also put some foam insulation, weather stripping around the 6-inch pipe here. Plus I've caulked around the inside edge of the pipe itself. It seemed like it's just going to sit there. The weight and the suction will hold it into place. So I just added a couple other little blocks here to help sort of balance the bottom plate of the blower. And you can see the short connection over here to the plenum for the filters that the exit of the blower will connect to. I mentioned this rotates in the opposite direction of the last blower, which connected over here, so I had to put an insert filler plate in here and caulked around that and drill a new hole here for the new entrance to the plenum. And here's the motor mounting itself. I have a cross piece here that fits nicely in the piece that was mounting on the motor bracket itself. This motor bracket actually pivoted on a steel pin here with a bolt at the other side that would add tension to the belt. Well, I didn't need any of that, but I found I was able to cut a 2x6 just to the right width to fit between the side pieces of this mounting, and it looks like it's going to work great. This is the bottom of the motor plate itself, which you saw in the previous drawing, and then this other plate down here is the top plate, the round part section cut out of the top plate for the blower assembly itself. Then once I can set this whole assembly on the blower, so I fit the blower in first, then just lower this in place on top of that, and there's just I don't know, half dozen or so screws I screwed in. It's not going to go anywhere, and mostly the weight will hold it down, but I wanted to keep it in place anyway. And you can see this is with the whole thing connected here. So this is the top of the blower plate, this is the bottom plate of the motor housing itself, and I connected the hose up here. Had to go down at a little bit of an offset because again the new fan was a little bit thicker than the old one, or taller, and with that taper in it, so it actually sits the blower housing just a little bit higher, but it's workable, and I don't think it restricts the airflow too much. I did find I had a couple minor holes or gaps in here from the hose to the mounting plate, so I took disassembled it easily and added some caulking in there to fix those minor leaks. And while I'm here showing this, I added a hose barb that goes into the side of the plenum and is drilled through. That allows me to then connect up to the pressure gauge to monitor the pressure of the plenum, or the back pressure of the filters. In fact, here was the hole itself. I took the plenum, and at Wind Environmental suggestion, I lined it, just I had some old carpet that I just cut it to size and just stapled it in place to help reduce the sound. Notice the hole here, this was for the original blower itself, and I've put a panel in here and actually moved that over to this side to access the new blower. And there's roughly 8-inch holes here that go down the center of the filter cartridges. I put some silicone beads along here and let it cure the first time around for attaching the top to it, and the top has this carpet in it also, but I found it was probably better. I ended up using weather stripping on the final assembly. As I put that together, I think it seals a little bit better. Now, to mount the filter cartridges to the plenum, I installed these carriage bolts, 8 carriage bolts, 4 for each filter, from the inside before I put the carpet down, and then just put nuts on it to hold them in place. Then I marked the positions on holes that I did in the flange, and I think in reality I actually did the holes in the flange first, tried to hold them in place on the plenum itself, then drilled holes up through in order to mount the carriage bolts. But once you get that, you just hold the filter cartridge up in place through the holes, and the holes were a little bit oversized because they weren't exact position, but they were close enough. Then I just added a washer, a lock washer, and a 1/4 inch nut on these to hold them in place. And there's really a nice filter gasket on this filter, which I think we'll see in the next slide here, and that seals it very well. Yeah, we see it right up here on the top piece here. So to do the filter cartridge assembly itself, it consists of 3 pieces, and actually one of the pieces is 2 pieces itself. So the cartridge is here, and it's open at the bottom end, and when environmental recommended that I use gamma seal lids, and sounds strange, but you can find them at Home Depot, and they're a screw-on kind of lid. And think, well, how is that going to work? I need it to be open to come through. And the way that works is you unscrew the bottom piece of it here, and you just pound it in place on the 5-gallon bucket. And on the top piece, you cut out the center of it, to match the diameter of the filter cartridge itself. Then there's clips that when environmental sells that help attach this top piece of the gamma seal lid to the bottom of the filter cartridge. Now I also added quite a bit of caulking around here before I set that in place. Then once it's set, I actually went back and caulked on the inside of the lid also. And when it's all done, then you just can take the bucket and screw it right on the bottom of the filter cartridge. So if you ever have to empty it, it's very easy to do. And here is the completed unit with the filter cartridges on, everything all painted up, and with the new motor and blower assembly up here on top. And I demonstrated this in part 3, did a quick video of how it works, but I'm really pleased on the performance of it. I then went through and did the test data again using the new blower, and here again, same as before, this is the test pipe, and I talked about that in video 4 on the input static pressure here. Then I also measured the static pressure in the input chute on the collector itself, measured the back pressure on the plenum going to the filters. Then I measured in 5 different places across, so I get a cross section of the airflow because it's not uniform on the pipe at the test pipe itself, and I used the Alnor velometer to measure that. It gives me feet per minute. And the second line, I used the Dwyer 166 pitot tube and a Dwyer Magnahelic pressure gauge to come up with the velocity pressure, which then converts to velocity in feet per minute. Then knowing the cross section, I then convert those to CFM, and I'm also measuring the current draw of the motor. And I mentioned it, I believe it's a 15 amp motor that I'm using on the 4 horsepower motor, so a little bit of a margin there, not a lot, but typically we'll see here in a minute, I'm probably going to be running it at the most probably in this range here, so should be okay on that. And we notice that the static, or the CFM has increased quite a bit from the 12.5 inch blower, and I'm now in a number of places over 800 CFM, and most places at least 500 CFM. So very pleased with that. And the noise level with the new blower actually went down just a little bit, and it's very comfortable to hold a conversation even with it running. So with the table saw or the planer or the joiner or the router running, you never even hear the dust collector. It's well within less than those sounds. And here's a performance curve now with the new blower in it, the blue line here. The red one is the old blower line. So where we were barely getting 800 CFM at less than 2 inches static pressure before, now we're up about 4 inches of static pressure, and so it's much better. Still not super great if you're trying to get 800 CFM everywhere, but at least you're up over 7 inches of static pressure and still getting 600 CFM. So for me, I think that's going to be very acceptable. Yeah, I still may need a larger blower if I'm going to install fixed pipes in order to try to keep in this range here. I haven't done the calculations on that yet, and given the setup in my shop right now, it's easy enough just to connect from one machine to another, being a single person shop. So I think I'll go with that with the 6-inch flex hose right now for that. And this is the same curves here, but just for grins, I threw in the original dust collection unit. Yeah, just a wee bit better on even the 2 horsepower unit, but with the 6 horsepower unit, it's just night and day difference now between the old unit here, which was barely a chip collector, and now we're in something that's I think gonna serve me very well. The efficiency, I went and calculated that again with the 14-inch blower. In this case, I ran 6 bins full of dust and chips through. It was 65 pounds per bin. I actually had a few more chips than the last time, so worked out to about 390 pounds of material I ran through it. As I mentioned on the last video, I get little suspect when on some of the YouTube videos that the builders just put, I don't know, maybe a shovel full of something through, and I don't think that gives an accurate measure of the performance. So anyway, so I probably went overboard, but ran a lot of dust through it, and again, the static pressure on the filters was only about 3/10 of an inch water column, so very low. And I would say the cartridges were now charged, and I did clean them out before I did this test, and there wasn't hardly anything left in it from the prior test. And I ended up with about 3.7 ounces or 0.23 pounds of fine dust in the bucket after cleaning. And that means the Cyclone itself before the filters is somewhere about 99.9% efficient. So yeah, I couldn't ask for more than that. Anything more than 99% I think is great. And even if we say, okay, well maybe I was off a little bit here and there's still more dust up in those filters after I blew them clean with the air compressor, that maybe I was off a little bit, okay, but it's still it's minuscule. Then I measured with the 6-inch flex hose now, the new performance measurements on both static pressure and CFM for each of my major tools with the 10-inch table saw. It's 4 inches of static pressure with producing 810 CFM. On the 12-inch joiner, it's 6 inches of static pressure, 700 CFM. The 15-inch planer, 5 inches of static pressure, 745 CFM. And the 16-inch bandsaw, 7 inches static pressure, 600 CFM. I have an older router table which has very small ports in it. It's actually got a 2 1/4 inch port on the top in the fence and one that goes down to the router itself, and that's the worst one. It's running about 10 inches of static pressure, and that's only given me 290 CFM. Yet I've found sort of it's centered right where you need to collect the dust, and even with the old dust collector I had, I was able to get almost all the chips out of it. So with 290 CFM, I think that'll be more than adequate for the old table. The new table, I have bigger hose going into it under the table, and it's about 600 CFM, and I've run some test pieces through that, and there's really nothing under the table anymore. It used to have quite a bit under the table, and now there's nothing under the table. So I'm pleased with that. and the performance there. Okay, there's a couple loose ends that I didn't get to in the last build video of part 3, so I just want to finish up with those. The first one is the magna helix. I didn't really get a close-up view of those. And the left gauge is a Dwyer 2030 magna helix, and it measures the static pressure coming in the input chute. And you want to connect that to the low pressure side of the gauge. Each gauge has a low and a high pressure side, and if you do it incorrectly, you'll destroy the gauge. So make sure you connect that to the low pressure side. And I probably could get by with about a 15 inch gauge itself, which would be a 2015 magna helix, but I had this in hand, bought it on eBay, and I'll probably just stick with that for now. On the right gauge, I'm using a 2005 magna helix, which goes 0 to 5 inches water column, and you connect this to the plenum tube on the high pressure side of the gauge, because you're coming out of the blower there. And so this allows me to measure the back pressure on the filters itself. Then I took that last chart we had on performance on the static pressure in the input chute on just 2 through 10 inches of static pressure, and took from my curve the CFM, the approximate CFM. So I can connect up to any machine, and if I'm getting 6 inches of static pressure, I know it's roughly about 700 CFM. Also, I noticed I did not show the Thien or the Thien baffle plate installed in the unit underneath the Cyclone cylinder. So I took a picture of this here from the bottom side, showing the weather stripping seal on it, which I did move after I painted the unit to line up with the inside edge of the collector bin. That way I don't get dust build up along that bin as there was a gap there. And I attach it with 3 just small pieces of wood here, and I did round over the edge on the top and bottom side of each of these cleats that hold it in place. I noticed when they were sharp right angle, I was getting some larger debris holding up on that. Since I've painted them and rounded those over, actually not necessarily in that order, I rounded them over first, then painted them, I haven't had anything catch on those cleats at all. You know, and if you get some large piece of wood that it sucks in there, or some large animal, or a cat or something, you want to keep your animals away from this thing. It really moves a lot of air. Anyway, you just take 3 screws out, lower the thing down, clean anything out of there, then put the 3 screws back, and you're back in business. And you just pull the bin out, and you don't have to take the whole thing apart. Just pull the bin out, and you have access to this underneath the cylinder Cyclone itself. Now, a couple things I did for modifying the pipe to be able to fit inside the current pipe or inside the hose is I cut a slot in the pipe. So I took about, I don't know, it's probably about a 5-inch section of pipe, cut a slot in it on my bandsaw. Then I took then I actually put the clamps around it first. I didn't mention this here. And I took a heat gun and heated it up and let it cool down so it stays in that shape. Then I just put some wood blanks in here to open it up to allow me to get access to the inside of that edge, add the primer, and then the pipe the pipe adhesive into it. Take the blocks out, it closes right up, and I add the clamps on until that sets. So we're good to go there. Then I sort of stole the idea from the general locking pipe mechanisms used for RVs. I just cut a slot in this here, then a slight angle, and I think I'm going to have to angle that down a little bit more so it's get a positive lock, and it keeps the pipe in place here. Then I just used a number 10 machine screw, screwed it from the inside of this adapter till it sticks out a little bit and just goes right in there and locks in place. I use this on both the dust collector itself as well as the pipes on each of the machine at the other end of the hose, and it works out quite well there. Notice this hose I got, which I also got from Win Environmental. I'm very pleased with the hose itself. Has a wire insert to it, and I'm going to talk about that next. The age-old question is, do you ground your hose or your pipe? And in the past, even working at it in the dry winter in Maryland, I didn't really have a problem with static discharge and moving the hose around. Occasionally I get that on my shop vac, but for this I really didn't have a problem. However, a week and a half ago I ran into a problem. I was recording a video. Actually, my daughter was holding the phone. I was connected with a wired lapel mic and got a static discharge as I was demonstrating the dust collector through the mic line and into the phone, and it fried the phone. It's the only thing I can guess, and yet my daughter jumped and said, "Oh, I either touched something sharp or I got a static discharge." Well, I guessed right away it was a static discharge. So I may try to ground the wire in the flex hose at the dust collector end to prevent any more discharges. And by doing that, I think I'm just going to peel back the vinyl here a little bit, put an alligator clip there, and ground it up to the motor ground itself. And hopefully that should prevent any issues with that, because once I get down close to the machine, I don't think there's an issue there at all. Okay, these are the machines that I have connected to my dust collector with a 6-inch port on all of them. The first one is my 16-inch bandsaw here. It has a 4-inch port, but then I immediately go from 4 to 6 inches and connect up to the dust collector that way. The next one is my old router table, and it actually had a 4-inch port on it that connected to two 2¼ inch ports, one for on top of the table and one for below. I just added a 6-inch port on the outside for that. The next is my 15-inch planer, and again it had a 4-inch port, but I immediately went to a 6-inch pipe so I could connect there. The next one is my 12-inch joiner, and it had two 4-inch ports come in here that I come into a Y to convert the two 4s to a 6-inch connection here. Next one is my new router table, and I have a 6-inch port here that goes to 4 and 4 inches under the table, then 2¼ going up to the fence. And the last one is my table saw. I have a 6-inch port under here, goes to a 3-way Y. The 6-inch goes straight through and up underneath the table. It's a contractor style table saw. Then I take a 4-inch port out the side, come up here across the top, down here for a shark guard with a top dust collection at the top. And this one's nice because I did not fasten this connection here, so I can just swivel it out of the way when I don't need that one, or if I'm changing the blade or something like that. The other Y port, I was wondering if I could use that for catching pieces where I'm just barely skimming a new edge off a piece, and it doesn't catch it all at the top. I haven't used that yet. I just have that one taped off. So that's my connections to the 6 machines in my shop, and they're sort of in a semicircle, so it's easy just to really quickly go from one connection to the another and make it easy. The one collector connection I may change is I know a lot of these bigger bandsaws also have a secondary 4-inch port at the bottom, and I may try to do one in the door here on the far side and go from a 6-inch to two 4-inch connections, one in the door and then one here up closer to the throat plate. Other than that, that's it for there. And in summary, the new blower increased the CFM and static pressure performance. The Cyclone efficiency is fantastic at over 99% on just the Cyclone itself before the filters. The noise level is very nice. I'm about 80, maybe 81 dB away, a DBC at 10 feet away. Very, very comfortable. On all of these machines, once you turn the machine on, you don't hear the dust collector at all. It's well below the noise of the machines. So with that, I'm still using hearing protection, even though I don't need it specifically for the dust collector. This unit should last me for many years to come with a cleaner shop. And just another reminder, yeah, I'm doing a whole lot better now at collecting the dust with this machine, but it's still really a good idea to wear a dust mask when working in the shop. It just, there's still stray dust that gets around, and even though it's a whole lot better than it was, it's still a good idea to do that. And this ends part 5, and I thank you so much for watching. And again, I appreciate any feedback or any questions that you have. And with that, have a great day, everybody.